right, so let's get started in the discussions of our welcome work. The first two were just some problems for fill in the blanks, definitions, and whatnot. So number one, we're looking for an equation used to compute probabilities of continuous random variables. Yes, probability density function. Good old PDF. Number two, a blank is an equation table, a graph used to describe model. They're used to model the world, so it represents the world in some way. Three, true or false, normal curve is symmetric about its mean mu. True. Yes. Four, the area under the normal curve to the right of mu equals?
I don't know.
1. The whole area equals 1. They want to know the area to the right of the mean. Is it 3%? Not 3%? No.
Isn't it 0.30? 90. No, 97?
What does the mean do to the normal curve?
Split in half.
Yes. So how much area is to the right of the mean?
50.
50%. 1/2. 0.5. Yes, the total area is 1. 1 is that special number we were talking about last time. If you, of course, look at the mean, which is at the center, it's going to cut it into 2 equal parts.
What?
Number 5 is talking about the location of the inflection points. Those happen based on the mean and the standard deviation. So the first one is going to happen where we have the mean minus the standard deviation. And the second one's going to happen where we have the mean plus the standard deviation. So that's what they were looking for there in number top there. Finally, number 6, the area under normal curve can be interpreted as, we have 2 mathematical keywords, probability and proportion. So those are 2 words that we needed there in number 6. Any questions about those first? The next ones we have the graphs, and we needed to determine whether or not they represented a normal situation. So we look here at 7 and 8. Do either of those actually, could they represent a normal situation?
I said number 8 could,
Okay.
not 7.
Okay, and why not 7?
Because it goes to the left. I actually think it was symmetric.
Okay, it's not symmetric. What type of shape would you qualify that as? Yes, right. So it doesn't meet the qualification of being bell-shaped, therefore it is not a normal curve. So not so good there, number 7, but number 8 is good. It definitely would could represent a normal situation. Any questions there? That's okay if that's wrong. That is okay. All right, the other 4. Which of those work?
I said 9 yes, 10 no, 11 yes.
11 is a definite. It's very similar to what we just saw in 8. It's a nice bell curve. All probabilities are positive. It's symmetric. All that stuff is good. Right. 9 is not right because it goes below the x-axis, so that's not allowed. What about 10? Allowed to go back up?
No.
No. So number 10 is a no as well because it tries to go back up.
Okay.
What about 12?
No, because they have a little peak at the top.
10 gallon hand doesn't work. So
Hold on.
you can have a little dip there.
Okay, so no because 10 is no because the curve, and 9 is no because it goes below x.
Correct. Any other questions on 9 through 12? Now 13 and 14 want us to reference back to our friend who's perpetually late, up to 30 minutes late from our examples 1 and 2 we talked about last time. So they're asking us for some probabilities. They're also asking us for some times. So we'll talk about how we worked that out a little bit. So for number 13A, again, we're dealing with our friend who's up to 30 minutes late. So we have our graph there from 0 to 30. What is the height of that graph going to be?
What was the information?
Is it 1 over 30?
What was the information about this?
The information is from examples 1 and 2 which I spoke previously. Same one we talked about last time.
Ew.
What's wrong? You're not one more. Okay, so then you want to peek in the window. You know, like scraper and stuff. So we have our graph where height is 1/30. We have from 0 to 30 as our time and space here. So in 13A, they ask us to find the probability that your friend is between 5 and 10 minutes late. So on our graph, we can of course shade the area between 5 and 10 minutes. Should be that beauteous rectangle there. Of course, in order to calculate that probability, we figure out the area of that rectangle. So we're going to take our width times our height in order to calculate our area. So what is the width of that rectangle? 3. Didn't think so. 5. Yes, from 5 to 10, so width is 5. And of course, we established that our graph is 1/30th tall. So we take 5 times 1/30th, and so there's going to be a 1 in 6 chance that our friend is between 5 and 10 minutes late. Questions? Now, B is asking us something a little different. B says it's 10 a.m. There's a 40% probability your friend will arrive within the next blank minutes. So what they're saying essentially is that 10 a.m. starting right here at 10 a.m. They want to know where along our graph would we reach a 40% probability. So we know that we're going to color in somewhere. We just need to figure out where we need to stop in order to create 40% of our probability. Now, let's be smart about this. We go from 0 to 30. Where's halfway? 50 minutes. So we know that our graph is going to be somewhere before 15 minutes will represent a 40% probability that they are here. How can we go about figuring this out? Well, we can actually use the area formula that we have in music. So we know that we want to have 40% probability, so that's our area of 0.4. We're not exactly sure how long that's going to take, so we're still looking for the width. And of course, we know the height of our graph. So we can use those two pieces of information to figure out our width, which of course will then give us our time period. So 0.4, 1/30th W. And then of course we can think about it in one of two ways. We can think about it as dividing by 1/30th, or we can think about it as multiplying by 30. Because of course 1/30th times 30 gives us 1. And 30 times 0.4 is going to give us a 12. So that means that 12 minutes will represent the 40% of our time. So if she arrives by 10:12, where there is a 40% probability that our person arrives by 10:12. Now the other thing to notice is that how the graph is set up. Well, as we're counting in between here, we said this is the 50% mark. Well, it turns out that we have 10, 20, 30, 40, 50%. We have 5 different division marks there, so that actually indicates that we have the 40%. Questions about 13? 14 wants us to find the probability that your friend is between 15 and 25 minutes late. So, of course, a similar situation. We're looking between 15 and 25. How wide is that rectangle? And then, of course, we have a height of 1/30th. So what is our probability? We'll fit over 30, so 1/6. And then I want don't think in your head and no. Question? And then B is asking us to do the same kind of backwards thing. It says it's 10 a.m. There's a 90% probability your friend will arrive within the next how many minutes? So we know that we want an area of 90%. We know our height, and we're looking for how much time we are going to have to wait for them to show up. So once again, we're multiplying by 30. So that will give us 27 minutes. Questions there? The last two questions are just looking at, again, at the same scenario. Number 15, they want the probability that you're at least 20 minutes late. So we have a width of 20. We have our height of 1/30th, so you should end up with 1/3 for number 15. And then find the probability that your friend is no more than 5 minutes late in number 16. Again, a width of 5 minutes, so you end up with a 1/6. Any questions on those two? All right, so if you will locate your homework, let's discuss that in a few minutes. Page 367. 17 and 18 started with some uniform questions as well. They tell us in 17, the random number generator on your calculator randomly generates a number between 0 and 1. Random variable x is the number generated, follows a uniform probability distribution. So we're generating numbers. And what is the range of our numbers? So we need to label our axis from 0 to 1. And so, of course, I didn't necessarily want to just put 1 right here, because that's going to make a very small amount of variation of color. So let's see, 0.1, 0.2, 0.3, 0.4, 5, 6, 7, 8, 9, 1. Now let's put an intermediate spots there. And so that, of course, is a uniform distribution, so it's going to be nice and rectangular.
So we don't make it correctly, but you don't count wrong.
Say again?
You don't make it correctly. What if we had just put 1?
Right, you just want to have a rectangle there, because that's the actual graph. All right, so then we need to figure out the height of our graph. How wide is our graph? 1. So what's 1 over 1? So the height of our graph is 1. That's going to make our calculations nice and easy, because we can multiply by 1. Any questions about the graph setup? Okay, B wants the probability of generating a number between 0 and 2. So we want between 0 and 0.2. How wide are we there? 0.2. And of course our height, 1. We have probability 0.2. So basically, in the case of this particular distribution, the width is going to be our probability. So C asks us for the probability of between 0.25 and 0.6. So 0.25 and 0.6. How wide is it between 0.25 and 0.6? So of course multiplied by 1. Finally, D says, what's the probability of generating a number greater than 0.95? Well, of course, you only have up to 1, so 0.05 would be that space. And so 0.05 times 1 would be 0.05. Any questions on 17? '18 is a little different because our reaction time that they're talking about here is between 5 and 10 minutes. So we don't have a 0 anymore for number 18. We're between 5 and 10. So we want to make sure when we create that graph that we skip over at least one space and have kind of a freestanding rectangle, because we don't want it to touch over there at 0, because 0 is not part of its probabilities, or part of its random variables. And so how wide are we? 5 to 10 spaces. So what is our height going to be? Good. Any questions about setting up that graph? Right, so remember that we can use our area formula. We know that the area of this whole rectangle can only be 1. And we can tell from the space of the graph that it's 1, 2, 3, 4, 5 spaces wide. So when we use our formula, we solve for the height, and we end up with 4 there. Any other questions? And so just like the previous problem, then they ask us some probabilities. Question B says, what's the probability that we're between 6 and 8 minutes? So we can, of course, locate 6 and 8 on our graph. Find that rectangle space. How wide are we between 6 and 8? 2. I feared. Only 1 or 2 people answering the question. C then asks us for the probability that the reaction time is between 5 and 8. Well, that's just 3 minutes now instead of 2. So 3 times 1/5 will give us 3/5. And then finally, D asks us for the probability that it's less than 6. So of course, less than 6 would be between 5 and 6. So that's 1 wide. So 1 times 1/5 will be 1/5. Any questions on 18? The next several gave us some histograms, and we were supposed to make decisions as to whether or not they could represent normal situations. So, number 19, the birth weights of babies. Is that something that would be considered a normal situation? It's fairly bell-shaped, so we can use the normal distribution to find probabilities. What about waiting in line for a roller coaster? No, not so much. Right? Wait, where's the tail? So it is skewed right. Because think about it, when you go into an amusement park, there's often times where you don't have to wait a very long time, but then there are some times where you have to wait mucho gracias time. So that applies. How about length of phone calls? Again, oftentimes you have very short conversations. There's a few times where you have extremely long conversations. And last but not least, the incubation time of some hens. Yes. Appear to be normal. Yeah. Bell-shaped, so yes, that is something we could use the normal distribution to calculate probabilities for. Any questions on those? 23 and 24 gave us some graphs with some information for the mean and standard deviation, and they want us to figure out which graph is which. I noticed in the information they gave me that the mean is the same, because of course the mean is at the center, so they both are centered at the same place. So it's our standard deviation that is going to be of importance. So we have a standard deviation of 3 and a standard deviation of 2. What does the standard deviation do to the shape of the graph? Spread out, whether it's taller or shorter, that kind of thing. So we have the two different standard deviations. If the standard deviation is larger, what does that do to the graph? It's short, it's wider. So of these two, which one is going to match our orange set of information? Yes, our blue guy, that is the one that is wider, and this one has the larger standard deviation. So of course that means that that guy is going to match. Questions about those relationships?
So the bigger the standard deviation, the wider.
Shorter and wider the curve. All right, now here at number 24, the standard deviations are the same, but we need to compare their means. What does the mean do to the graph? They look the same, so their shape is basically the same, but what is different about them? Where they're located, so it shifts it around. So which of our graphs is going to match the orange information? And of course, when we're looking for the mean, we're looking for the center, and you can see here that the center of this guy is an 8, and the center of that guy is a 14, so maybe go in that order. Any questions on those relationships? Next up, they gave us 4 different graphs of normal curves, and they wanted us to identify the mean and the standard deviation. Obviously, the mean is generally the easier one because it's where the center of the graph is. So let's determine those first. So what is the mean in number 25? 2. About 26. 27. And last but not least, 30. Okay, so we just find the center of the graph. That tells us the mean. Any questions on finding the mean? Now, the standard deviation is also on the graph in some way. Is it a number that I can just look at and say, like mean? No. Where do I need to look to find the standard deviation? Okay, we need to look at space. Basically, that is between our numbers. And so that space, of course, should be consistent across all of the labels that are there on the x-axis. And that space is our standard deviation. So what is the standard deviation for number 45? Oh, 3. It's 2 plus 30 gives us 5. All right, how about 26? 2. That's 27? 15. And last but not least, big old 100.
You always look to the right.
You can look to the left. It doesn't matter because it's always going to be a consistent amount.
If you look to the left, when you know when the standard deviation would be -3.
No, so because you're going 5 minus 3 is 2. 7 minus 5 is 2. 9 minus 7 is 2. When you see, like in number 25, for instance, that you get into the negative number, that's because we take 2 minus 3, which is -1. -1 minus 3 is -4. Any other questions about identifying? The next two, they actually wanted us to draw our own. So hopefully you got a little practice in drawing your own curve of normalness. So make a little x-axis with a little hill. In this case, they wanted a mean of 30 and a standard deviation of 10. So somewhere over here we should have a 40, and somewhere over there we should have a 20. Questions about 29? And then 30 was similar. This time we had a mean of 50. So that will be at the center. And then our standard deviation of 5, so we're adding on 5 and subtracting off 5. The last one that we worked on was a multi-step problem. The first thing they wanted us to do, again, was to create the graph. They told us that we have cell phone plans that we're looking to with a mean of $62 and a standard deviation of $18. So I have that graphed and labeled. The next thing they wanted us to do was to shade the region that represents the proportion of plans that charge less than 44. So less than 44, of course, would be going here in the other direction. So I want to shade over that way. And then last but not least, they want us to discuss two interpretations using those two keywords that we mentioned earlier. So one with probability and one with proportion. So we have two sentences that apply. First one, we of course want to talk about probability. Talk about cell phone plan costs. And of course use the number that they gave us there in the problem as being the actual probability. Similarly, we write a sentence using the word proportion. And figuring out how many will cost us. Any questions? All right, so at this point you will need three things. First thing that you will need is a piece of paper. We have a few short note type things that we need to write. Second thing you will need is a piece of graph paper from the table over here. You will also need at least one, you can get more, but you need at least one colored pencil. So take a moment and put those supplies.